In this video, we're going to talk about how to convert back and forth between polar and rectangular coordinates. So I have here just a general setup, and what you have is your X and Y axis. So your origin, again, acts as your pole. Like I already mentioned, the pole and the origin are pretty much the same idea. And then you have your initial axis here. So your theta works the same way. And then what happens is your point r comma theta is going to give you the same coordinate as x, y, just in a different format. So kind of think of it like different units here. And how are they related? Well, x is the same thing as r times cosine theta. Y is the same thing as r times sine theta. We do know that x squared plus y squared equals r squared. And then also tangent theta is y over x. So those four key pieces are how we can relate the two ideas. So we're going to try converting both ways. First, we're going to find the rectangular coordinates for the polar coordinates. And this is, I think, the easier way, going from polar back to rectangular. So what we do here is we use the first two formulas. And that's all we're going to do to convert back. So for A, our R is 2 and our theta is 3 pi over 2. So our X will be 2 times cosine of 3 pi over 2. And our Y will be 2 times sine of 3 pi over 2. Now 3 pi over 2 is at 270 degrees there, and the cosine value at that is 0. So 2 times 0 is 0. And the sine value there is going to be negative 1. So our point 3 pi over 2 becomes instead 0 comma negative 2. Let's move this down. Which hopefully makes sense. So I'm not going to draw every single one of them out, but sometimes it helps to see that quick drawing. This is my purple for my axes here. So if I'm going to 3 pi over 2, right, I'm going down to here. So I'm going out this way for my terminal side. And then it's positive, so I'm staying on the terminal side I've drawn, and I'm going down 2 units. So my point is right here. And you can see that this makes sense to 0, negative 2. It's the same point. It's the same sort of location. It's the same location, not sort of, same location on the graph, just a different way to express it, a different kind of unit system. So you can see sometimes graphing helps just to really show you that, yes, this is the same idea. This is the same point. For B, our R is negative 8 and our theta is pi over 3. And again, a lot of times your theta is values that you know. If it's not, you could always use your calculator if it's okay to estimate for that point as well. So you could use your calculator to get a decimal approximation if you needed to. But I think a lot of the values you will know. So it's going to be negative 8 cosine of pi over 3. And negative 8 sine of pi over 3. All right, so for this one, for cosine of pi over 3, you're looking at 1/2. So that value is negative 4. And then for sine of pi over 3, we're looking at root 3 over 2. So negative 4 root 3 there. You could round that if you needed to, but it's better to leave the actual value unless it says to round or approximate. So I'm going to leave that here. So our point negative 8 pi over 3 becomes the point negative 4 comma negative 4 root 3. Again, not to draw every single one because I'm not going to. If we think about this, so pi over 3 is about like right here. Now it's negative 8 though, so you're going on the opposite side and we're going out 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So there's that point. And what happens is that matches up with the point -4 times √3. So -1, 2, 3, 4. And then again, that would be the same value of -4 √3. You can approximate that with your decimal. So it is the same point on the graph. Remember, these units are going diagonal because they're like circular, whereas these are going linear. So it makes it a little bit hard to match up, but they do actually match up in that realm. Okay, we can go the other way as well. Now, when we do this, because you could have many different thetas and many different r's, we're going to convert such that r is greater than 0, and 2, our theta is between 0 and 2 pi. So when we go from rectangular coordinates, we're going to use the following. Again, because you can get more than one representation we've already seen. So for our initial representation, we're going to keep the r positive, and we're going to keep our angle between 0 and 2 pi. And of course, you can always tweak afterwards if you need to. So let's do some examples here. So let's see. We're going to find the polar coordinates for the rectangular point -1, √3. So this is your x, this is your y. So the first thing you're going to do here is it does help to plot it. So your book does recommend to graph and to plot the point xy. So let's see. Now, √3 is about 1.7, I think. Let me just double check on our calculator here. Yeah, about 1.7. So you can do this as, let's say, 1, 2. So our point is about at -1 and maybe like right here. So our point kind of looks like this. So this distance coming out here is your r value. Now, for the work, what we actually really need to do here, the second thing you're going to do is you're going to find r, and we use that r is equal to the square root of x squared plus y squared, right? Because r squared is equal to x squared plus y squared. So here, r is going to be the square root of -1 squared plus √3 squared. -1 squared is 1, and √3 squared is just 3. That root cancels out. So we have square root of 4, which is 2. So our r is going to be +2 in this case. And finally, and this is probably the hardest step, is we're going to find theta using the fact that tangent of theta equals y over x. So here, let's see, we have our tangent of theta is equal to our y value is √3, our x is -1, which is -√3. Now, if you look on your graph here, you're going to notice that you are in the second coordinate, which makes sense. Your tangent would be negative in that coordinate. And we can do a few things here. If you know this theta off the top of your head, we've made quite a few charts at this point. So if you know the angle there that's in the second coordinate, you can go ahead and list it. If you forget, though, we can always do the inverse tangent of the positive value. So remember, we do that. We do know that is going to be pi over 3. So hopefully that's a value, again, that you know. So if you don't have all the tangent values, you should at least have them, in the first quadrant somewhere. So we do know that tangent of pi over 3 is equal to √3. And then instead, we're going into the second coordinate. So now we need to second quadrant, excuse me. So what I can do is I can take that 180 degrees and go ahead and subtract it with pi over 3. And I get 2 pi over 3. So remember, for the second coordinate work, you're always subtracting with 180 degrees, or if you're in radians, with pi. So there's different ways you can do it. Again, if you know this already, if you recognize that, hey, I know tangent of 2 pi over 3 is negative square root of 3, then you're done. We can go right to that step, and that's totally fine. Hopefully you'll know a lot of these as we're going through all the homework, and you're kind of, getting used to seeing the same values over and over again. If you don't know that though, use your positive version first, because we typically do have charts for this. This is a common one, so you should know that this is pi over 3. And then recognize that you are in the second quadrant here, so you do need to subtract with 180 degrees or with pi radians. So that is that final piece. And then now we can go ahead and put it all together. So -1/3 becomes, let's see, our r was 2, and then our theta is 2 pi over 3. All right, I'm going to do one more of these. These tend to be the harder ones, like I said. All right, so I'm going to find polar coordinates for the rectangular point -2, 0. And again, your first step should just be to give a quick graph there. This one's nice and easy to graph, -1, -2, 3, etc. So we're looking at this point right here, right? All right, so this is step 1. Step 2, we're going to find r. You can find it by x squared plus y squared. So our r here is going to be -2 squared plus 0 squared. -2 squared is 4, and obviously 0 squared is 0, so this is just a square root of 4, which is 2. So you have that value 2 again. And then here is the one where you're going to actually need to find your angle. So this one you can do a few ways. You can actually just look at this. In the last example, you need to find this angle here, right? This is actually the theta right here. So if for some reason you know that answer already, if you recognize this point and you know the theta, you can convert to that very, very quickly. But if you don't know it, you have a bit of work to do. Here, you actually can recognize that this angle is 180 degrees, right? So this angle is just pi. We can do this one off the top of our head. We don't have to go through the whole process. However, if you don't recognize that, you can go ahead and remember that tangent theta equals y over x. So in this case, tangent theta equals 0 over -2, which is 0. And tangent theta equals 0, obviously in many places, it equals 0 at 0, but it also equals it at pi. And because we want, I guess it's not in the second coordinate, but it's just past the second coordinate here. We do want to be over here. We don't want to be at angle 0. We want it in the angle here. So pi is going to be the one that works in this case. Okay, so that is the one that we're looking for.